Education Builder students. I'm so excited because I know by the end of this lesson, you will be able to use, recognize, and apply the various properties used in mathematics. First, we're going to go over the terms. We're going to define algebra, talk about what algebra is and what it means. We're going to define variable and coefficient, and you're going to know what equivalent means. Then we're going to go into real details about the three properties of mathematics. We're going to talk about the commutative property, the associative property, and the distributive property. Can't wait to see you there. Welcome, Education Builder students. The first thing we're going to do today is start off by talking about the key terms that you'll see used in today's lesson about properties. The first term we're going to define is algebra. The reason we want to define this is because students always say, when am I going to use algebra? I hate algebra. When am I going to use it? Well, algebra is a math language used to model real-world problems. So anytime you use math in the real world, it's basically algebra. The second term we're going to define is variable. A variable is a symbol, usually a letter, that can stand for different values. I put an example problem right here. 3a. What is a variable in this problem? Well, if the variable is a symbol and it's usually a letter, then the variable in this problem is a. The next term we're going to define is coefficient. A coefficient is a number multiplied by a variable. Normally, usually in math, it's the number in front of the variable. Remember, a variable is a letter. So here's an example, 7x. Well, what's in front of this letter? What's being multiplied to this letter? 7. So 7 is our coefficient. Another term is equivalent. Equivalent means same or equal. For example, what is 2 plus 3? 2 plus 3 equals 5. So 2 plus 3 is equivalent. Here's an equal sign. Here's a symbol for it. 5. Now we're going to define the three properties often used in algebra. The first property is a commutative property. The commutative property is the sum or product stays the same when the order is changed. Next, we're going to talk about the associative property. The associative property tells us that the sum or product stays the same when the grouping is changed. And lastly, we're going to go into detail about the distributive property. The distributive property is the product of numbers, and the sum or difference of two numbers is equal to the sum or difference of two products. This might seem like a foreign language to you, but by the end of this tape, you will understand how to recognize and apply the three properties of algebra. Now we're going to go into more detail about the commutative property of algebra or mathematics. Remember, we defined it as the sum or product stays the same when the order is changed. That's very important. Remember, sum is the answer you get when you add numbers together, and product is the answer that you get when you multiply numbers together. What this is basically telling you is the commutative property only works for addition and multiplication. Let's look. It said when the order is changed. The answer stays the same. Remember, that means equal when the order is changed. We've got A plus B equals, now if the order changes, it would become B plus A. Now remember, we said it was for addition. It works for addition, so let's see. Is 5 plus 3 the same or equal to 3 plus 5? Yes, because you get 8 on one side and 8 on the other side of the equal sign. So this is an example of the commutative property for addition. Let's look at another one with multiplication. We have A times B equals, now remember, commutative property is when the order changes, B times A. So now we're going to try it with numbers. Is 7 times 2 equal to or the same as 2 times 7? Yes, because we get 14 on both sides of the equal sign. 7 times 2 is 14. 2 times 7 is 14. And this is an example of the commutative property of multiplication. 7 times 2 is 14 once again, and 2 times 7 is 14. Now let's look here. It says the commutative property does not work for subtraction or division. Let's see why. If we have A divided by B, will it equal B divided by A? Well, let's try it with numbers to see. 4 divided by 2 is 2. And 2 divided by 4 is not 2. 2 divided by 4 is 1/2. So they do not equal each other. This is an example of why the commutative property doesn't work for division or subtraction. Let's look at a subtraction one. Is A minus B equal to B minus A? We use the numbers 5 and 2. 5 minus 2 is 3. But 2 minus 5 is negative 3. You don't get the same answer on both sides of the equal sign. So this is another example of why the commutative property does not work for subtraction or division. Remember, it only works for the sum, which is addition, and the product, which is multiplication. To help you remember the commutative property of mathematics, I want you to know that the word commute means to move or travel. Let's think about that. When you're at home during the year on a school day, you're getting ready, you might be at home and you wake up and you eat breakfast, and then you ride the school bus or your mom might take you to school. So you're going from home to school. Now when you're at school, chances are at the end of the day you're going from school and you take the bus back home. See, you have two locations. You have home and school, and everything's the same except the order changes. This can help you remember the commutative property. The sum or product stays the same when the order is changed. From home to school equals from school to home. Now remember, this only works for addition and multiplication. Let's go over some practice problems. Does x plus y equal y plus x? Well, when we add two variables together, we don't know what the answer is. So let's think about it. Is it an addition problem? Yes. Is everything the same but the order? Let's look at this. Didn't we have h plus s, home plus school, equals school plus home? Everything is the same on this, and it's an addition problem except for the order. So this is the commutative property of addition. Let's look at the next example. Is 5 times 4 the same as or equal to 4 times 5? Now that we have two numbers, we can work it out. 5 times 4 is 20. And is 4 times 5 20? Yes. So this also works out for the commutative property of mathematics. Let's look at this next example. We have 10 plus 12. Is 10 plus 12 equal to 12 times 10? You might be saying, Miss T, well, you said it works for addition and multiplication and the order changes. Well, let's look at that. Remember, at the end of the commutative property, you need to have the same answer on both sides of the equal sign. 10 plus 12 is 22. Now, does that equal 12 times 10? Just take a moment to think about that. 12 times 10 is not 22. It's 120. So does this work for the commutative property? No. This does not work. Even though it works for addition and multiplication, if it's addition on one side, it needs to be addition on the other. Remember, everything is the same except the order. You have a plus sign on this side of the equal sign, so in order for it to work, you would have to have a plus sign on this side. Let's go over the next example. We've got 1 plus 2 plus 3. Is that equal to 3 plus 2 plus 1? Well, it looks like we have plus signs on both sides, even though we have 3 numbers now instead of 2. And it looks like we have the same number, except the order changes. We have 1, 2, and 3, and 3, 2, and 1. Let's see. 1 plus